Good afternoon, everyone. Today we're going to find an equation of a line, and there are many ways we can do this. So the first thing I'm going to show you is how to find an equation of a line in slope-intercept form given a slope and a point. So let's go ahead and do that. Okay. So we want to find an equation of a line having a slope of 2 and passing through the point (-1, 7). And we want to express this in slope-intercept form. So maybe I should probably write, and slope-intercept form. All right. So here we go. The equation that we're going to use is the point slope form. Okay. So the equation that we're going to use is point slope form. And the reason why I want to use this is because this is used often. I want you to be familiar with both equations, so that when you see the one of them, you'll know the difference between them. Okay? So, all right, and that's going to be y minus y1 equals m x minus x1. Okay, so remember the m is the slope, so we don't want to forget that. M is the slope. And the point that we're going to use is going to be labeled x1, y1. Okay, so really easy to do. So we use this formula, and we're going to go ahead and plug in some numbers. Okay, so remember the point that we're going to use is, in this example, it's going to be (-1, 7). All right, so your (-1) is your x1 and your 7 is your y1. And your slope in this case is going to equal 2. And they give us that in the problem. So all we do is we go ahead and substitute everything in. Okay, y1 we said was 7. All right, our slope is 2. And then our x1 is (-1). So we're going to subtract a (-1), so we should enclose that with parentheses. And if we can go ahead and simplify the two signs in the parentheses, that becomes x plus 1. And normally now this here, this part of the formula, okay, right here, is in point slope form. So if they were to ask what is the point slope form, you would just stop there and that would be it. But we're going to continue, okay, because we want it in slope-intercept form. So that means we're going to have to solve for y. And remember, we're going to distribute the 2 with the x and the 1. So that's going to give us 2x plus 2. And then, of course, we're going to add 7. So that these cancel. And you're just left with y equals 2x plus 9. And that equation is in slope-intercept form. Okay, so you can convert from one form to another. They're both equivalent, it's just different ways of expressing it. Okay, so that would be your answer for that. All right, so the next one is we're going to find an equation and this time we're going to find an equation given 2 points. So the 2 points will be 1, 2 and 4, 8. All right. So the best way to do this is label the points correctly. So I'm going to label that as x1, y1, x2, y2. Basically what I'm doing is I'm choosing my first point to be designated as 1, 2. My second point will be 4, 8. So it's always going to be your first x coordinate, first y coordinate, and then your second point is your second x coordinate, second y coordinate. Once you do that, now we're going to have to calculate the slope, because I need a slope to plug into the formula, the slope-intercept formula. So I'm not going to be able to do anything yet until I calculate the slope. Unlike the previous example, the slope was given. This is not given. Instead, they give us 2 points, so that should give us an idea that we should calculate the slope. Remember the formula? y2 minus y1 over x2 minus x1. So if we go ahead and do that and substitute the points, y2 is 8, and then we're going to take away 2, x2 is 4, and we're going to subtract 1. So 8 minus 2 is 6, 4 minus 1 is 3, 6 divided by 3 is 2. So my slope is officially 2. All right? And then we're going to use that formula, remember? Y minus y1 equals slope times x minus x1. That is your point slope form. And remember that was given as my slope is 2 that we just calculated. And now when we do this, we can choose a point. So it really doesn't matter which one we choose. I'm just going to choose the first one. So I'm going to choose 1, 2. And again, that is going to be called x1, y1. And then we just go ahead and plug everything in, and we should be good to go. All right? So you can choose either point. When they give you 2 points, calculate the slope. Choose a point, label it x1, y1. Now plug everything into the formula, and then you should be good. So y1 in this case is 2. Our slope is also 2. And our x1 is 1. Again, if we stop there, that's the point-slope form, but we want to practice getting into the slope-intercept form, so we're going to do a little more algebra. Okay, we're going to distribute the 2 over the parentheses. Okay, and then you're going to get y minus 2 equals 2x minus 2. Go ahead and add 2 to both sides. You notice that the 2's cancel, and you're just left with y equals 2x. And that is your equation of a line given through 2 points. All right? So let's do another example. This time I want to find an equation of a line parallel to another equation. Okay? So, so basically what we do is okay. So again, we're doing the same thing, find an equation. And this time we want to find an equation in slope-intercept form that's going to be parallel to y equals minus 7x plus 2. And containing the point -3 comma -2. So this line is going to contain this point, and it's going to be parallel to -7x plus 2. All right? So before we find an equation of a line, we want to find the slope. Okay? Now remember, from the previous video, I did a video about parallel perpendicular lines. And remember, I said that parallel lines have to have the same slope. So if the first equation, okay, if the first equation has the slope equaling -7, then my line that's parallel to it, which will be my second slope, must also equal -7. And that's why I call it M2, my second slope, okay? So when we go ahead and do that, then we can go ahead and just write down the formula that we use, okay? Y minus y1 equals m times x minus x1. All right, and what we want to do is we want to plug in this slope, okay, for here. Because remember, we want to create a second line that's parallel. So if the line is parallel, then we should use the same slope, -7. So I have to designate my slope as -7, okay? And then the point that's given to us was -3 comma -2. Remember, that is going to be x1 and your y1. All right? So now all we do is plug everything in, and then we're good to go. So y1 in this case is a -2. So remember, we're subtracting a -2. So there should be a set of parentheses with a negative inside. Equals a -7. X minus x1. Again, that is -3. And then now we simplify all the signs, and then we should be good to go. Okay? A negative and a negative is a positive, so that turns that to a positive. And then here we're going to simplify the two signs in the parentheses. That turns into a positive. And then now I'm going to distribute the 7 over the parentheses to get rid of the parentheses themselves. Okay, so y plus 2 equals -7x. And then -7 times 3 is -21. All right, and then I'm going to go ahead and subtract the 2 because I want to solve for y. Now if I stop here, okay, this is my point slope form. Remember? But I want to keep going, solve for y, and when I do that, subtract the 2 on both sides, these cancel, then I'm just left with y equals -7x. -21 minus 2 more is -23. Okay, and I have my equation that is now in the slope intercept form. Okay, sorry, sometimes it's hard to write and my pen slips, so I'll try to write as neatly as possible. So hopefully you can read that slope intercept form. Okay, so, and that's it, and that's all you do for that one. Okay, so the other example is we want to find an equation of a line that's perpendicular to another equation or another line. Okay, so we can do that, an example in the next slide. Okay, so we're going to find an equation, this time that's perpendicular to x plus 3y equals 20. All right, and containing the point -3, 4. All right, so the best thing to do, interestingly enough here, we have an equation, if you notice, that this right here is in standard form. It's not in slope-intercept form. So we don't really know what the slope is, right? So what we're going to have to do is we're going to have to convert that to slope-intercept form by simply going ahead and solving for y. Okay, so we're going to do that by subtracting the x on both sides. So that cancels. Then you're just left with 3y equals, instead of writing 20 minus x, we're going to write minus x plus 20. Then we want the x term first. And then we divide everything by 3. Okay, the coefficient of 3 cancels. Then you're just left with y equals minus 1/3 x plus 20 over 3. Again, there's the negative x, as you can see, it has a coefficient of -1. So you can write -1/3 and then write the x off to the side, or you can write negative x over 3. I like writing the -1 over 3 instead, so you can see it. So now this equation is in slope-intercept form. And you notice that the slope here is equal to minus 1/3. Okay? So what does that mean? Well, basically, you can do this, okay? If you see equation in standard form, get it into the slope-intercept form. And now, if you want to find the second equation, then we need to look at the slope. So a slope that's perpendicular, if you want the slope to be perpendicular, then we take the original slope. So the original slope, remember, we calculated to be -1/3. Okay? So we want to find a perpendicular slope. So the perpendicular slope is going to be the negative reciprocal. All right? So, okay, first of all, the reciprocal of, you know what? Let me go ahead and do this. Let me rewrite this. I don't like the way I rewrote that. Let me go ahead and do this. If you want to find the slope that is perpendicular, then that's going to equal -1 over that. So we take the first slope, and we do the reciprocal, and then change the opposite sign. So in this case, m2 is going to be, the opposite of negative is positive, so the reciprocal of 1/3 is really 3 over 1, which is equal to 3. So my new slope is going to be 3. Okay? That is the perpendicular slope. That's why it's important to get it in slope-intercept form, which we said in the first equation was -1/3. If we do the reciprocal of 1/3, it's 3 over 1, and then you make the negative into a positive, and then you get positive 3. So when you do the equation for that, I'm going to have to do this on the next slide. Okay, we're going to go ahead and write it down. Y minus y1 equals m times x minus x1. Okay, and remember that we used a point. Our point that was given was -3, 4. So we're going to label that as x1, y1. And then my slope that was perpendicular, remember, we said was 3. And we got that from the previous slide. So now we're going to plug everything in. Y1 was what, 4? Okay. And our slope is going to be 3. X1 is going to be a -3, so we're going to put a set of parentheses in that. And then now go ahead and continue to simplify. Okay. A negative and a negative is a positive. And now we're going to distribute the 3 over the parentheses to get rid of them. So we apply the distributive property, and then you have y minus 4 equals 3x plus 3. And our goal is to solve for y, so I'm going to add 4 to both sides. And then that's going to be y equals 3x plus 7. As you can see, that is now in slope intercept form, which is what we want. Okay? And over here, this was called point slope form. They're both correct, but we should know how to go from one form to another, okay? Because that'll be asked sometimes, often, when homework assignments are given in classes. They'll ask, what is it in point slope form, then what is it in intercept form, slope intercept form, and that just requires a little algebra to manipulate the equation to get it to look like the form that you want it to. And that's the answer for that. Y equals 3x plus 7. That line is perpendicular to our original equation, x plus 3y equals 20. Okay? I just noticed something really quickly here. I apologize. Let's go ahead and erase this here. I need to erase that, and I need to erase that. Here's why, because 3 times 3 is not 3, it's actually 9. Okay? So when we add 4 to it, then that should give us 13. Okay? Okay, so as long as we identify what we did, we're good. So when we distribute 3 times x is 3x, 3 times 3 is 9. So that was just a transformational error, I apologize. And then now we add 4 to both sides, and we get 13. So now we're good. That is the answer. I hope that this was very helpful, and hopefully that it'll explain how to convert, how to find a parallel line, a perpendicular line to a given line, or whatever the given situation is. That may be thrown at you. So hopefully this will help you. Thank you so much for watching, and I'll see you in the next video.